Hi, grade 11s. How are you feeling about 7.1? We're going to go through the questions from 7.2 again now for me. And I'll try to keep this one a little bit more brief. So looking at number 25, I think this is the, let's just write this equation out. So this is the one where we are using a hydrocarbon and nitrous oxide to form acrylate, is it? Or some sort of synthetic textile. So it's very interesting. Most of our textiles are synthetic. Okay, and they come from, believe it or not, fossil fuels. So just like always, we're going to set up our table. And now when we set it up, we have two different numbers to put in. I have a 126 grams of this hydrocarbon, and then I have 175 grams of nitrogen monoxide. So this one, I have to figure out who's the limiting reactant, who's going to have less moles, or who's going to, well, really it's who has less moles, but who's going to finish the reaction first. Whichever entity has the lowest number of molecules or particles or whatever, and it runs out the quickest, it's going to be the limiting reactant, okay? Just like, say, for instance, in your car, what's your limiting reactant to your how far you're able to drive? It's how much petrol or how much gas you have in the tank. And once the gas is used up, you can't go any further, even though your battery's good, you have windshield wiper fluid, everything like that. What really is involved in the reaction is gasoline. Okay, so we have these two entities here. We have to figure out which one is the limiting reactant, who is less. So what I can get off of the periodic table is my molar masses. Okay. And then now I'm going to find the number of moles for each of these entities. So again, because I'm moving down the table, it's going to be division in both cases. So 126 divided by 42.09, I get 2.9936 moles. Am I going to leave it at that? No. I have to account for my coefficient of 4. Because 4 of these, I think it's propylene, 4 propylene are going to react with 6 nitrogen monoxide. This ratio will affect which one's limiting. And so you have to always divide by the coefficient. Okay. When I come here, I have 5.8314 mole. When I divide 175 by 30.01, and then I have to divide by 6 here. So I get 0.9719 moles. Okay. So it's these two numbers here that we're going to compare. Which one's less? And the answer is propylene. Okay. So we can say, therefore, propylene is the limiting reactant. Awesome. Okay. That one's pretty easy. And I'm going to do number 28 because that one is going to ask you, can you find out the mass that's left extra or left over? For instance, in this, we know that there's excess amount of nitrous oxide. It's the question's not asking us to do it, so we aren't going to do it. But let's go on to number 28, where it is going to ask us more information. I completely forget what this is called, but I know that we're mixing it with hydrogen peroxide to get, do you remember the name of this? Nitric acid and water. Good morning. I have to record the video again. Okay, so let's look at this here. We know that we have mass, molar mass, number of moles, and number of moles with regards to the coefficient. The first thing I'm looking at is, wow, 1:7 ratio. That's a big ratio. So when I have equal amounts of 120 grams, I don't care that it is equal mass. And because the ratio is 1:7, it's probably going to be hydrogen peroxide. Let me just do a check to make sure that it's recording my screen. Yeah, good. So now, of course, let me change the color. Let's do red this time. Let's fill in the information that we need from the periodic table. 32.06 grams per mole for this nitrogen, hydrogen. And then we have 34.02 grams per mole for hydrogen peroxide. We're going to divide because we're going to go down the table. So I did 120 grams divided by 32.06. And now, do I have to do anything to get to this xn? No, because it's only coefficient 1. So N2H4 has 3.7430 moles available for reaction. Whereas when I do 120 grams divided by 34.02 grams, I have around the same number for hydrogen peroxide, 3.5273 moles. But when I divide it by 7, because of the coefficient, I get 0.5040 moles. Way, way, way less. So this is more. And so who's my limiting reactant? Hydrogen peroxide is my limiting reactant. Okay, so you can write that down. Therefore, H2O2 is limiting. It's going to run out. The second part of the question is asking how much nitric acid is being produced. So remember, it's this number here that we're going to pull over. It has the numbers scaled for the coefficients. And so I'm going to put 0.5040 moles. What am I multiplying by? I'm multiplying by 2, 1.0078 moles. And then the molar mass for nitric acid is 63.02 grams per mole. So I get a total of, 63.5 grams of nitric acid is produced. Okay, and that was just by going up. Now, the question that I mean, universally grade 11s have difficulty with this question. So I'm going to try my best to explain it because it's not too difficult. It just it involves a little bit of manipulation. It's asking for the amount of excess N2H4 that's left over. We know just looking at this number, it's 3. I'm going to look at these two numbers here. Okay, they're not, the coefficient is not accounted for in these two numbers. So for C, when I'm trying to find the number of moles of excess of N2H4, I'm going to take 3.7430 mole, subtract 0.5040 mole, and I get 3.239 moles. Now, you have to multiply it by the coefficient. It just so happens that my coefficient for this question is 1. Okay, so really If you missed that step, you wouldn't get the wrong answer because it's scaled to 1. Yeah, and so there's 3.239 moles of N2H4 excess. Now we're going to find the mass. How much does that weigh? So I'm going to take the number of moles and multiply by the molar mass. And voila, 104 grams excess. And remember my prediction that the 1:7 ratio, it's a lot. When we compare how much is left over to how much we began with, only 16 grams of N2H4 was used up, and it's because of the 1:7 ratio. All right, enjoy your weekends, guys. I'm not going to answer anything until Monday, but I wanted to get this done for you guys, unless it's absolutely urgent. And take care.